students and viewers, it's my hope that you are doing good. My name is Ramadhani Kideghesho, a teacher of chemistry. Today I'm going to teach the topic which is called chemical kinetics, equilibrium and energetics. The subtopic which must be covered in this topic of chemical kinetics, equilibrium and energetics, including the following. The first one is the rate of chemical reaction. The second one is the factor affecting the rate of chemical reaction. Third is the reversible and irreversible reaction. Fourth is equilibrium reaction. And the last is endothermic and exothermic reaction. Now, the rate of chemical reaction. Students, what is chemical kinetics? Can you try to define chemical kinetics? Now, chemical kinetics can be defined as the study of the rate of chemical reaction. Chemical kinetics can be defined as the study of the rate of chemical reaction. Now, what is the rate of chemical reaction? Can you define the rate of chemical reaction? Okay, the rate of chemical reaction can be defined as the measure of the progress of the reaction per unit time. It's the measure of the progress of the reaction per unit time. Or, also you can define the rate of chemical reaction as the speed at which reaction proceeds per unit time. The speed at which the reaction proceeds per unit time. All these are definitions of the rate of chemical reactions. Now, the rate of chemical reaction is determined by measuring amount of the reactant used up or amount of product formed at a particular time taken. Now, mathematically, the rate of chemical reaction is equal to the amount of the reactant used divided by the time taken. That's the first formula. Or the second formula, time taken. The rate of chemical reaction is equal to the amount of product mass per time taken. Because here in our formula we have seen that the rate of chemical reaction is the amount of reactant used divided by the time taken, or the amount of product used formed divided by time taken. So this amount of reactants or amount of product can either be in volume or mass or concentration. So I hope that you know the unit of volume, you know the unit of mass, you know the unit of concentration. So in case you have been given in volume, the volume of reactant or product, and then they ask you to calculate the rate of reaction. Now you are going to use the unit of volume which you have been given. Or if you have been given the concentration, then they ask you to calculate the rate of chemical reaction. Now, the unit which you are going to use here is the unit of concentration. So, the units of the rate of chemical reaction depend on the unit of reactant or product used. Now, from the graph of the amount of a substance, maybe volume or concentration, of reactants or product against time, the rate of chemical reaction is given by the slope of the graph. So in case you plot the graph of amount of a substance, and that amount can either be in volume or concentration of reactant or product against the time, the rate of chemical reaction will be the slope of that graph. Mathematically, the slope of the graph is equal to change of x over change of t. Slope of the graph is equal to change of x over change of t, or divided by change of t, where Change of X is the change of amount of reactants or products. And the change of T is equal to time, change of time taken. Change of time taken. Now, by dividing this change of amount of reactant or product divided by time taken, change of time taken, what are you going to obtain in the slope of the graph? And that slope is the rate of chemical reaction. Now, if the plot of product against time, if the plot is the product against time, the slope will be positive. Why? This is because the amount of product increases with time. So in case you plot the graph of product against time, the slope will be positive. Why? Because as the time gone, the amount of product increase. Now the slope will be positive. But if you plot the graph of reactant against the time, the slope will be negative. Why? Because the amount of reactant decreases with time. As the time gone, the amount of reactant decreases. So the slope will be negative. That's a point to note. Now, question. In an experiment of determining the rate of chemical reaction, the following volume of gas were recorded in every 10 seconds. Now here you have the table, and which show the table here, which show the time and the volume. How the volume is recorded at a particular time. In every 10 seconds, I mean the volume was recorded as it is shown here. As it was 0, the volume was 0. After 10, the volume was 18. 20, the volume was 20. 30, the volume was 40. 40, the volume was 48. 50, the volume was 53. 60, the volume was 57. 70, the volume was 58. And 80, the volume was 58. Now, as the time gone, the volume of reactant was, the volume was recorded. The volume of product formed was recorded as it is shown here in the table. Now, the question says, plot the graph of volume against time. Students, it's my hope that you can draw the graph. You can plot the graph of volume against time. In case they ask you to plot the graph of volume against time, the volume will be in the y-axis and the time will be in the x-axis. Now to plot the graph is very simple because here you have the number. You have the number. Now it's my hope that the student you can draw the graph or you can plot the graph which you have been asked here. You have to try it. The second question says determine the rate of chemical reaction. As I said earlier, that the rate of chemical reaction is the slope of the graph of volume against time. Now, the graph which you plotted of volume against time, you find the slope of that graph. The slope will give you the rate of chemical reaction. Now, it's my hope that you can attempt this question. I leave to you. You have to attempt it. Okay? Comparison of rate of chemical reaction. Comparison of rate of chemical reactions. The rate of chemical reaction can be fast or slow. Now, consider the following rate of chemical reaction. First, high rate of chemical reaction. High rate of chemical reaction. High rate of chemical reaction are all chemical reactions which take short time to complete reaction. High rate of chemical reaction take a short time to complete a reaction. It can either take a second or a minute or a hour, but the time taken to complete the reaction the reaction is very short. Okay, now let us look the comparison of rate of chemical reaction. Rate of chemical reaction can be fast or slow. Dear students and viewers, do you know when the rate of chemical reaction is fast or when the rate of chemical reaction is slow? Can you give me the example, some examples of reaction which have the fast rate of chemical reaction and is some reactions which have slow rate of chemical reaction? Okay, consider the following rate of chemical reaction. Firstly, higher rate of chemical reaction. The high rate of chemical reaction are all chemical reactions which take short time to complete a reaction. Are all chemical reactions which take short time to complete reaction. For example, neutralization of acid and base is one of the examples of reaction which have high rate of chemical reaction. Now, example, hydrochloric acid and the sodium hydroxide to obtain sodium chloride and the water. This is the example of the neutralization reaction, and this reaction takes place very fast. Once they mix up, the product, which is sodium chloride and water, is formed. Another example of the reaction which have high rate of chemical reaction is the reaction of colorless potassium iodide and lead nitrate to form yellow lead iodide. The reaction of colorless potassium iodide and lead nitrate to form yellow lead iodide. Now, potassium iodide, once reacting with the lead nitrate, the product here is the potassium iodide and the lead nitrate. This reaction here is the double salt decomposition, and this reaction takes place very faster. It takes place within a short period of time. Now, secondly, low rate of chemical reaction. Low rate of chemical reaction are all chemical reaction which takes long time to complete reaction. For example, decomposition of hydrogen peroxide in the absence of manganese 4 oxide catalyst. So if the manganese 4 oxide, which is the catalyst, is absent, the decomposition of hydrogen peroxide will take a long time. Now, hydrogen peroxide, the product is water and oxygen. So the decomposition requires manganese 4 oxide in order the reaction to react very fast. In order for this chemical to decompose very fast. Another example is rusting. Rusting of iron is another example of the reaction which takes place at a very low rate of chemical reaction. And rusting, the reaction is between iron, oxygen, and water. And the product which is formed is hydrated iron 3 oxide. So the formation of hydrated iron 3 oxide takes a long time. It can take a week, a year. So this is another reaction which takes place at a low rate of chemical reaction. Clear, students? Okay. Now the second subtopic is the factor affecting the rate of chemical reaction. Factor that affects the rate of chemical reaction. What are the factors that affect the rate of chemical reaction? Can you mention the factor that affecting the rate of chemical reaction, students? Can you list it? Okay, you have to list it. Okay, thank you. The factor that affecting the rate of chemical reaction including the following. The first one is change in temperature. The second one is concentration. The third one is the surface area of reactants. The fourth one is addition of catalyst. And the last one is pressure. So these are factors that are affecting the rate of chemical reaction. Now I'm going to explain one after another. Starting with change in temperature. How change in temperature affects the rate of chemical reaction. Students, can you explain how the change in temperature affects the rate of chemical reaction? Can you give me the explanation of it? Okay. Now, the increase in temperature tends to increase the rate of chemical reaction. Increase in temperature tends to increase the rate of chemical reaction, and vice versa is true. I mean, the decrease in temperature tends to decrease the rate of chemical reaction. So, why increase in temperature tends to increase the rate of chemical reaction? What's the reason behind? This is because when the temperature increases, the reactant particles acquire kinetic energy and move faster. So the reactant particles acquire the kinetic energy and move faster. So this increases more effective collision of reactant particles. And you expect once these particles collide, they fuse and form the product. So for that case, as they move faster due to the kinetic energy which acquired due to the high temperature, I mean the more effective collision between reactant particles will increase. The more effective collision between reactant particles will increase. And for that case, the rate of chemical reaction will increase. And vice versa, is it true? In case the temperature decreases, I mean the particle will not acquire the kinetic energy and they will move slow. And for that case, the rate of chemical reaction, the collision frequency between reactant particles will decrease. And for that case, the rate of chemical reaction will decrease. Now, that's the reason why the change in temperature affects the rate of chemical reaction. The second is concentration. Now, how the concentration affects the rate of chemical reaction? How concentration affects the rate of chemical reaction, dear students? Can you explain? Can you explain why concentration affects the rate of chemical reaction? It's okay. Now, the increase in concentration also tends to increase the rate of chemical reaction. Why? This is because of the increase of likelihood of reactant particles. The number of particles which react increase. So, which leads to the increase more effective collision of reactant particles. So, once those particles which react increase, I mean the collision frequency also will increase. And for that case, the rate of chemical reaction will increase. Now, number 3 is the surface area of reactant particles. Surface area of the reactant particles. How the surface area of the reactant particles affects the rate of chemical reaction. The size of the reacting particles influence the rate of chemical reaction. The size of the reacting particles influence the rate of chemical reaction. Now, the smaller the size of the reacting particles, the larger the surface area, and thus the faster the rate of chemical reaction. Once the size is small, I mean the surface area to reaction will be large. And for that case, the rate of chemical reaction will increase. Here I have an example. The lump of marble chips, calcium carbonate, reacts slowly with dilute hydrochloric acid because the particles of marble chips is large. Now, these particles will react very slowly with dilute hydrochloric acid. While powder of calcium carbonate reacts faster with dilute hydrochloric acid. If it is in powder, the particles are very small. For that case, the reaction between this powdered calcium carbonate and hydrochloric acid, the reaction will take place very faster. Now, the smaller the size, the larger the surface area, and thus the faster the rate of chemical reaction. The faster the rate of chemical reaction. Number 4, addition of catalyst. Now, how the addition of catalyst affects the rate of chemical reaction? Dear students, can you explain why the addition of catalyst affects the rate of chemical reaction? Now, what is a catalyst? Can you define catalyst? Can you tell us how the addition of catalyst affects the rate of chemical reaction? It's okay. Now, what is catalyst? By definition, you can say catalyst is a substance which speeds up the rate of chemical reaction but remain unchanged at the end of reaction. This one here speeds up the rate of chemical reaction but remain unchanged. At the end of the reaction, the catalyst remains as it is. But the function of catalyst is to speed up the rate of chemical reaction, to make the reaction react faster, to make the reactant particles to react faster. That's the function of catalyst. Now, catalyst increase the rate of chemical reaction by lowering the activation energy required to start the reaction. So this catalyst here increase the rate of reaction by lowering the activation energy. So what is activation energy, dear students? What is activation energy? The function of catalyst here, we have seen that is to lower the activation energy. Can you define activation energy? Can you tell us in short about activation energy? Now, what is activation energy? By definition, you can say activation energy is the minimum energy possessed by reactant particles in order to undergo the chemical reaction. Minimum energy. Each reaction has this minimum energy. It's the energy barrier which is possessed by particles in order to undergo reaction. So for the substance to react, they must overcome the energy barrier which is called activation energy. In order the substance to react, or in order the reactant particles to react, to form products, they must overcome this energy barrier, which is called activation energy. So this energy barrier, or the minimum energy possessed by reactant particles, this energy barrier must be possessed by the reactant particles during the reaction. Now, all reactant particles must possess activation energy for the complete of reaction to occur. In order for the reaction to occur, all reactant particles must possess this activation energy or this energy barrier. Now, thus, the catalyst speed up the rate of chemical reaction by lowering activation energy. So the function of this catalyst is to lower the activation energy, to lower the energy barrier. Now, the last is pressure. Can you tell us how the pressure affects the rate of chemical reaction, dear students and viewers? Can you tell us briefly? Can you explain briefly how the pressure affects the rate of chemical reaction? It is like this. Pressure affects the rate of chemical reaction of the gaseous substances. Point to remember, pressure affects the rate of chemical reactions of gaseous substances. I mean, once the gases react to form products, I mean, the pressure can affect the rate of chemical reaction of these gaseous particles. Now, the increase in pressure brings the gaseous particles close together. Those particles will come together. If they come together, I mean, this increases effective collision. The collision frequency will increase, and in turn, increase the rate of chemical reaction. Increase the rate of chemical reaction. So that's how the pressure affects the rate of chemical reaction, and vice versa is true. In case the pressure decreases, I mean the particles will be far away. The particles will be far away, and the collision frequency will decrease, and for that case, the rate of chemical reaction will be slow, will be low. Now, let us discuss reversible and irreversible reactions. Now, types of chemical reaction. There are 2 types of chemical reactions, including the following. The first one is irreversible reaction, and the second one is reversible reaction. So these are the types of chemical reactions. Now, what is a irreversible reaction? Can you define irreversible reaction, dear students? Can you tell us in brief about irreversible reaction? Okay, irreversible reaction is the type of chemical reaction which proceeds only in forward direction. This is the type of chemical reaction which proceeds only in forward direction. When I say in forward direction, I mean the reactant changes to product, but product cannot change to reactant. That's all about irreversible reaction. Now, it is represented by a single arrow, which means the reaction proceeds in forward direction. We use a single arrow to represent it in the chemical reaction. For example, a certain element reacts with a certain element, we use a single arrow to show the reactant and the products. Reactant used and the product formed. Now, for example, reaction between zinc metal and dilute hydrochloric acid to form zinc chloride and the hydrogen gas. The reaction is like this one here. Zinc reacting with 2 hydrogen chloride or hydrochloric acid, and then we obtain zinc chloride and the hydrogen gas. This reaction here is a irreversible reaction, and we use the arrow here to show these are reactants and these are products. This arrow shows that only reactants can change to products, but the products cannot change to reactants. So this here is an example of irreversible reaction. Now, reversible reaction. Students, can you define reversible reaction? From the knowledge which you have obtained from irreversible reaction, now can you try to define a reversible reaction? Okay, reversible reaction can be defined as the type of chemical reaction which proceeds in forward direction, in both the forward and the backward direction. I'm repeating again. Reversible reaction is the type of chemical reaction which proceeds in both forward and backward direction. It is represented by double arrow, which means reaction proceeds in forward and backward direction. Now we use it double arrow to represent a reversible reaction. Now example. Gently heating ammonium chloride decomposes to form ammonia gas and hydrogen gas. Now here, this is ammonium chloride. This is the ammonium chloride. The product formed here is ammonia gas and hydrogen chloride gas. Now, what have been used here is the double arrow. So this double arrow here shows that the reactant can change it to product, but also the product can change to reactant. This is a reversible reaction. Now, summary of what we have learned at this period. We have learned the rate of chemical reaction, have discussed a lot about the rate of chemical reaction. Also have discussed the factor affecting the rate of chemical reaction. It's my hope that you remember all factors that affect the rate of chemical reaction. And lastly, we have discussed the reversible and the irreversible reaction. Now, I have the exercise here. So the question said, define the following terms. Chemical kinetics. Students, it's my hope that you can define it. Rates of chemical reaction. Can you define it? It's my hope that it is very simple now to define it. It's very possible to define these two terminologies. Now, the second question says, describe 4 factors that affect the rate of chemical reaction. Describe 4 factors that affect the rate of chemical reaction. To describe this, you explain. After mention, you explain it. It's my hope that you can mention and explain all factors that affect the rate of chemical reaction. Now, can you do it? It's my hope that you can do it. The third question says, differentiate between reversible and irreversible reaction. Differentiate between reversible and irreversible reaction. It's my hope that you can differentiate it, and in each you can give an example of chemical reaction which are reversible and which are irreversible. In case of differentiating, you give the definition of these reversible and irreversible, and you give the examples of which of these. Now, can't you do this question? It's my hope that you can do this question. Now, this marks the end of my presentation. You were with me, Sir Ramadhani Kideghesho. Thank you for listening. Wish you all the best. We shall meet in the next period where we will discuss another subtopic of this topic of chemical kinetics, equilibrium, and energetics. Thank you very much.
Enlab Innovation Academy inatangaza nafasi za masomo ya Information Technology kwa ngazi ya certificate na diploma kwa wanafunzi waliomaliza kidato cha 4, kidato cha 6 na chuo NTA Level 3. Chuo kipo Kinondoni Vijana jijini Dar es Salaam. Zaidi ya kusoma, mwanafunzi anapewa nafasi ya kuanzisha mradi wa kiteknolojia pamoja na kupatiwa mentor wa kumwongoza. Pia tunamsaidia mwanafunzi kutafuta scholarships pale anapohitimu. Tupigie leo 0677 071 486 au 0744 100 au tembelea tovuti yetu www.nia.ac.tz.